Okay, as I said on Friday, everybody, today's lesson is really just an opportunity for you to make sure you're solving the problems that were assigned on Friday correctly. So this is Friday's assignment, which is due today, but here's how to solve each one. Hopefully you've already tried to do these problems yourself, in which case this is an opportunity this would be an opportunity for you to get the problems correct. And if you're just copying down my work, it doesn't really help you. What you should do is watch the video on how to solve them. Problem 1, for example, that I'm going to show you here in a second. Then see if you can, without the video, do it, and then go back and check to see if you've done it correctly. All right, so problem number 1, here we go. So just an equation. Okay, it's got one variable in it in several spots, just a variable x. So it's a linear equation in one variable. And our methodology is first let's simplify each side. The right-hand side is already simplified. It's only a 5x, so we don't have to do anything there. On the left-hand side, we can do some distributing. We got a half times x, which we write as a half x, or 1x over 2. I like to put my x in the numerator, but you don't need to. You can put it off to the side. So you could have it written as 1 over 2x like this. Now, even more, at least to me, at least simpler, I think, is to just write it as an x over 2, which is still a half x. Then we have to take half of 3 here. So 1/2 times 3. Remember when you multiply fractions, I'm doing it off to the side here, that 3 is like a 3 over 1. Okay, and when we do fractions, we just multiply straight across. 1 times 3 and 2 times 1. Okay, now it is going to be a negative number because it's a positive half times a negative 3, so we just put negative 3 halves. The second set of parentheses right here don't mean anything except this was a group. Okay, but if you think of it as distributing a 1 out in front, it's not going to change anything if we drop the parentheses. So that second section without the parentheses is just 3 halves minus x equals 5x. So there's our first step, just distributing that half and dropping the parentheses. Now let's look for some like terms we can stick together on the left-hand side. So I've got an x over 2 minus an x. Okay, those are like terms. They're both x to the first power terms. And then we've got some constants here, numbers with no variable associated with them. Negative 3 halves plus 3 halves. Okay, a couple ways to think about this fraction a half minus 1. Remember, when we're dealing with combining like terms, all we're dealing with is the coefficients. So think of this as a half, take away the 1 that's in front of this x right here. Half minus 1 is just going to be a negative half. So all we have to do is worry about those coefficients. So that's going to be a negative half x. Again, I'll stick with the notation I was using before, negative half x like so. Negative 3 halves and positive 3 halves, those are additive inverses, so they just cancel each other out, and that adds up to 0, and so that equals just the right-hand side 5x. Okay. At this point, we've got x's on both sides, so let's get our x's on the same side together. Okay. So to do that, I have to move it with addition or subtraction. So I'm going to add x over 2 to the left side, and I'm going to add x over 2 to the right side. Left-hand side, they cancel each other out. Those are opposites of each other, or additive inverses. The other side, I've got 5x's plus a half x. Well, that's 5.5 x's if you want. In fact, you can even write it as 5.5 x's if you'd like. Okay, you could write it as 0 equals 5.5 x's if you'd like. And you can also make that a top-heavy fraction. You can write it as 11 over 2 x's like that. Those are all identical to each other. And I think in our minds, you sometimes just have to make the adjustment and decide, well, does it make sense better for me working with decimals? Does it work better for me working with the mixed fraction? Or does it work better as an improper fraction? In this case, I kind of like this decimal. I think it's easy to add 5½ with decimal values. And then our last step to get that x alone, just divide away 5.5 on both sides. So x equals 0 divided by anything is 0. So x is 0. And we are done with problem number 1. Problem number 2. Let's take a look at ourselves an equation. Left-hand side looks like we have some like terms. Right-hand side doesn't look like any like terms. So let's combine like terms first. I'm going to highlight them for us. It's a w term minus 12w's. So 5w minus 12w's, and then the 8, but no one's like the 8 on that left-hand side. Remember, we have a left-hand side and a right-hand side on the equal sign. Okay, left-hand side, there's two like terms. We can combine those. 5 minus 12. Well, that's just going to be negative 7w's and our plus 8. And that equals 16 minus 15w's. Okay, I've used those colors to indicate what my like terms are. Okay, I want to get all my variables on one side. And in this case, I'm just going to, and in general, I usually try to put my variables on the left. So I have to undo this minus 15w on the right-hand side. And I'll undo that by adding 15w. It would be the opposite of it, and they would cancel each other out then. But that means I have to do it to the left as well. Notice I line it up underneath the 7w term. On the right-hand side, my whole intent there was to get rid of that completely, so I'm only left with that 16 on the right. On the left-hand side, I've got to do a little bit of math. Negative 7 plus 15, that's 8w's, plus 8. So all of my w's now are on the left-hand side, and now I move anything that doesn't have a variable with it to the other side. In this case, it means move it to the right-hand side. Well, it's 8w plus 8, so I'm going to undo that plus 8 by subtracting 8. And I end up with 8w. 8 minus 8 are gone now. And 16 minus 8 is just 8. And then my last step is I undo any multiplication or divisions. I've got a multiplication, 8 times w, so I divide by 8. And it looks to me like we end up with 8 over 8 is just 1, so w equals, and 8 over 8 is just 1. W is equal to 1. Problem 3, we got ourselves an equation. Okay, two terms on the left, but they aren't like terms. Two terms on the right, but they're not like terms. So we just start by trying to get all our variables on the same side. Again, I'm going to try and get stuff to the left, at least my variables to the left. So I'm going to subtract 6y from the right-hand side and do the same to the left. When I do that, I get 7 minus 6, which is 1y. We just write y for that. 6 minus 6 will cancel, leaving me just 11. Wow, this turned out to be a really simple problem. My very last step, I got to get rid of that 5, so the y is alone. It's y plus 5, so I subtract 5. And I end up with y equals, you see, 5 minus 5, 6. So a little 30-second problem. Problem number 4 looks a little bit tougher. Before we even look for like terms, it doesn't look like we have any, but we're just going to distribute, okay? And we're going to do the same thing to the right-hand side. We've got this number, then the parenthesis, and then we have an addition. So this is distributive property of multiplication over addition, is its technical name. All right, so I've referred to it in class sometimes as the rainbow method, but we should be calling it the distributive process. All right, so 1.2 times x is easy. That's 1.2 times x. 1.2 times 5, you can use your calculator if you need it, but 1.2 times 5 is 6. On the right-hand side, 1.6 times 2 is, 3.2x. And 1.6 times 5 is 8, I believe. Okay, so now we left to see if we have any like terms on the left. There are none. No like terms on the right. So let's get all our variables on the same side. This time, I think I'm going to get my variables on the right. And I'll explain why I'm doing that as I go. So I subtract the 1.2. And by moving it to the right-hand side, it has allowed me to keep my coefficient in front of the x to be positive. And it's much easier to take 3.2 minus 1.2 rather than the opposite and have to deal with negative numbers. And so it was a little bit of a thought process before I decided, but that's all what I'm doing, trying to keep my coefficient positive. And 3.2 minus 1.2 is 2. Now I move everything away from my x term, so I'm going to subtract 8. Giving me negative 2 on the left-hand side of my equal sign, and giving me a 2x on the right. And I undo a multiplication with division. X is equal to, it looks like, negative 1. And again, we're going to write that with the x on the left-hand side, like so. All right, problem number 5 here. It kind of looks tough. Whenever I see these fractions, a lot of students panic. Don't worry. This is just distributing a 3 times this t, or negative 3 times t, and then negative 3 times 4/3. Okay, so if we think of it in small steps, it can turn into a manageable problem. So we've got a t, and then negative 3 times t is just negative 3 times t, negative 3t. And then negative 3 times 4/3. Okay, you could get out your calculator and just type in 3 times 4 divided by 3. That would work. Off to the side here, I'll show you the actual math for it, though. When you take negative 3 times 4/3, remember that negative 3 is over an implied 1, so it's really negative 3 over 1. And we just multiply straight across. So it's negative 12 over, multiplying straight across in the denominator 3, which is just negative 4. Okay, so negative 3 times 4/3 is negative 4. And as a side note, if you understand fractions, because this is multiplication here, it really just, this 3 in the numerator cancels the 3 in the denominator. So it's really just negative 1 times 4, which gives you the negative 4. But regardless, whether you do it with a calculator or you crank it out by hand, you should get negative 4 as a result. And look at how much simpler that problem now looks. Okay, on the left-hand side, we have no more parentheses. We do have some like terms here that we can put together. So let's go ahead and I'll highlight those. 1t, take away 3t's, so that's negative 2t's, minus 4 equals 2t plus 3. And so now we're ready to get our variables all on the same side. Now we could move this negative 2t to the right with addition, or we could subtract this 2t and move it to the left. Okay. In this case, again, I usually like to get variables on the left, not always, but in general, that's what I do. So I'm going to subtract the 2t from the right, so I'll undo it from it being on the right-hand side. And then I have to do the same to the left, and I line it up again underneath its like terms. So the t terms are underneath each other, or aligned. So that gives me a total of negative 4t's minus 4 equals, they've canceled out on the right-hand side, 3. Now I move anything that doesn't have a t to the right, so I'm going to add 4. I'm trying to get it away from the side with the t on it. And the result there is negative 4t. These are additive inverses and cancel each other out, equals 7. And finally, I undo that multiplication with division. And so I'm going to end up with negative 4 over negative 4 is 1t, which is just t we write, equals 7 over negative 4. Now in general, we don't put that negative in the denominator. Usually we're going to put that up in the numerator. It's just easier to see when we put it on top like that. And that is it for problem number 5. Problem number 6. Look too bad. Left-hand side, we can see we can distribute this 3. Right-hand side, we can distribute the 2. So we go 3 times x, which we write 3 times x, and 3 times 1. Positive 1, so it's a positive 3. On the right-hand side, 2 times x, which is 2x, and 2 times 11, which is 22. Let's get our x's on the left-hand side, so we'll subtract 2x. Again, doing it to both sides of that of the equation. They cancel on the right. On the left-hand side, 3 minus 2 is just 1x, or x. We move any numbers away from x using addition or subtraction. So we're going to subtract 3. And it looks like we have x all alone on the left-hand side, which is what we want. And 22 minus 3 is 19. Number 7. Let's see here. Let's look at the left-hand side. We've got a distributive property we can do. Right-hand side, there's no like terms. So let's go ahead and distribute. It's kind of nice with decimals. 0.5 times c is just 0.5c. 0.5 times 2.8, the way you want to think of that is half of 2.8, which is just 1.4. Minus c equals 0.6c plus 0.3. You'll notice they put these 0.5 and 0.6 and 0.3. You don't necessarily have to put that 0, okay? The reason that's done quite frequently, though, is when you see a 0 like that, it indicates to you, oh, there's probably a decimal next, so it helps us to see the decimal. Okay, so it's just a way to help visualize and not miss a decimal point. So let's look at this left-hand side, see if we get any like terms. Again, here's our equal sign, so I'm looking on the left. And it looks like I've got a half of a c, take away a full c. And those are the only like terms on the left-hand side. Well, 1/2 take away 1 is negative 0.5. So negative 0.5 c's plus 1.4 equals 0.6 c plus 0.3. I'm going to get all my c's. Let's see here. I'm going to put my c's on the right-hand side this time. So I'm going to add 0.5c, because those two are additive inverses. They'll cancel each other out. And I do the same thing to the right side. On the right-hand side, I get a different result. So left-hand side, I'm left with a 1.4 equals 0.6 plus 0.5 is 1.1c plus 0.3. I'm going to move that number, that 0.3 now, away from the c side, the right-hand side, by subtracting 0.3. And they cancel each other out. And I have to do the same to the left-hand side. On the left-hand side, 1.4 minus 0.3 is 1.1. And on the right-hand side, I'm only left with a 1.1c. And finally, I have to get c alone, so I undo multiplication with division. Divide by 1.1. Those will just give me a 1c on the right-hand side. And on the left-hand side, 1.1 over 1.1, same numerator as denominator. That means it is equal to a 1. So c is equal to 1 in problem 7. Problem number 8, I am not going to do. And the reason I'm not going to do 8 is because you can skip it. It's exactly the same as number 6, so that was an error by myself. So you got yourselves a freebie, and you can just write skip, or same as number 6. All right, last we have problem number 9. Now problem number 9, there's a couple ways that we can do this. We can see, first of all, that we have got like terms. These are all u terms. We've got u divided by 5, or 1/5 of a u, 1/10 of a u, or u over 10, and subtract 1/6 of a u, or u over 6. The first way I'm going to show you how to do this is by getting common denominators. Okay, so you have to figure out what the common denominator of 5, 10, and 6 are. To find common denominators, everybody will list the multiples of 5, 10, 15, 20, 25, 30, 35, etc. And the multiples of 10, 20, and 30, 40, etc. And 6, 12, 18, 24, 30. And I'm going to stop right at 30 because you'll see at this point, I didn't want that 30 erased. You'll see at this point, they all have, they're all multiples, or one of their multiples is 30, and that is the least common multiple. And the least common multiple means that makes your best or smallest common denominator. So I'm shooting for 30 for all of these fractions. So let's go ahead and see how we get that denominator of 30. Okay, what we do is we take each fraction times whatever it takes to make a 30 in the denominator. For the first fraction, 6 times 5 is 30, so I multiply by 6 over 6. Now remember, 6 over 6 is equivalent to 1. So while it will change the way it looks, making it 6u over 30, it is still equivalent to 1/5. Okay? To get the 10 to be a 30, I take the second fraction times 3 over 3, which gives me 3u over 30, still equal to 1/10, 3 over 30, but now it has a denominator of 30. And the last one I take times 5 over 5, because 5 times 6 is 30, giving me 5u, still equal to 1/6. And since I'm only multiplying by ones, I don't have to do anything to the right-hand side. I could take it times a 1 if I wanted to, but there's really no reason to. Okay, once I have a common denominator, when we add fractions, we just combine their numerators. So this is really just 6u plus 3u minus 5u. Well, 6 plus 3 is 9, and 9 minus 5 is 4u. All over that common denominator equals 1. So now I got to just get rid of that 4/30ths. And to get rid of a fraction times a variable like this, we just multiply by the reciprocal, 30 over 4. Do it to the other side to keep things balanced. What happens when you do this is the 30 cancels the 30, the 4 cancels the 4, giving you just u equals 1 times 30 over 4, which is 30 over 4. Okay, that can be reduced, so u is going to be 15 over 2, or 7.5. Okay, so that's one way to do it. Now I'm going to erase all of this, and I am going to, hopefully this will all clear, see what happens, see if we can trash it. Alright, well that didn't work well. I'll just erase it with my eraser. So we saw how to get a common denominator to get all of the fractions combined. Here's another cool technique. Now we already know or saw how the common denominator would be 30. So another technique you can use is to multiply everybody times what that common denominator would be. So I've multiplied the left side by 30, which means each term times 30, and the right side times 30. Now the right side, the math is easy. I get 30. The left-hand side, this is kind of cool, since 30 is a multiple of 5 and a multiple of 10 and a multiple of 6, that means they can all be divided into that 30. So 30 divided by 5 is just 6, so that is now 6u. And 30 divided by 10 is 3, so it's 3u. And 30 divided by 6 is 5, so that's 5u. So in this case, by multiplying by what the least common multiple is of the denominators, I can get rid of all the fractions at once. And now it becomes easy. It's 6 plus 3 is 9. 9 minus 5 is 4u equals 30. I divide by 4, and u is 30 over 4 again, or 15 over 2, or 7.5. Either those are the best answers for what u is. So hopefully you followed those methods, everybody. Make sure you get all your homework correct, because there's no excuses except for watching a video that tells you how to do every single problem.